Up next, we are honored to have the man that the Internet Hall of Fame calls the father of the Internet. When he worked at DARPA, he set it all in motion and co-wrote the code for what we now know today as the Internet. Dr. Kahn has turned his attention to making websites and their content durable through digital object architecture. He has received the Presidential Medal of Technology from President Clinton, the Presidential Medal of Freedom from President George W. Bush, and more prestigious scientific and engineering awards than we even have time to list here today. It is a great honor to introduce to you Dr. Robert Kahn as our first keynote speaker.
Okay, well, thank you for that, Pri. And I'm wired both on a lavalier so I can walk away, but we may see a little bit of interaction between these two if history is any guide. So, first of all, thank you very much for asking me to talk to you today, because I think what you're doing is something extremely important. I think this whole issue of blockchain technology is very important for a number of reasons, but probably the most important of which is the fact that it raised the issue of trust in a very fundamental way in the public debate. So I just want to say a few words about that. I've also been told that originally to put in some words about the origins of the internet, and then I was told we didn't have enough time for that. Now I'm told maybe we do have a little time. So I'm not going to spend most of my time in memory lane about the internet, but I would like to tell you a few relevant things that I think would be important today. So what the blockchain initiatives have the potential to do is really deal with trust in certain cases where they haven't been able to engender that in the past. And it's done it in a way that doesn't seem to require you to rely on any one specific external source. Having said that, I'd also like to say thank you for doing that, because without initiatives like this, these issues don't get the same kind of visibility that they really would need. However, having said that, I do want to point out that if you go and talk to people in different disciplines, not everyone will agree that blockchain, whether they understand it or don't, is going to be the ideal solution for them. I mean, I've already had several people write into me and say, well, what about the fact that it takes so long to do this, or you got to spend so much energy doing that? And so I think there's going to be a hybrid of approaches that work, of which this one may be extremely important in certain areas, especially the financial industry where it kind of seemed to have originated. But what I would like to do today, and I hope you take this all in the right spirit, is to say that what's going on here in many ways is new, but in many ways is a logical continuation or a use of things that have been in the public for many, many years. And I'd like to just sort of give you that context. This is not to say that the credit goes somewhere else, but rather to say, when you look at what you're doing, put it in the right global perspective. So that's what I want to do today in the time I have. Share a little bit about the origins of the technology and show you where the blockchain activity fits within it. Now, let me say a few things about the internet. When we started working on that many years ago, the original notion that many people had was the internet itself was proprietary. In fact, I was at meetings where people told me they couldn't even take up and think about the internet because it was a proprietary technology of ours. We said, no, it wasn't. It really originated with government funding, came out of DARPA, as was pointed out originally when I was back there. And it didn't take very long before people looked into it deeply and said, oh, I guess it isn't. And you see what happened with the internet from that point on. Some of what I'm going to raise today has also been brought up in the same context. People have said this whole issue of managing information is part of a proprietary architecture. I'm here to tell you that no, it isn't. It's open to everybody, and we would encourage you to look at it in that context. And blockchain fits into it in a very natural way. In 1972, to put this back in time, I organized the very first demonstration of computer networking at the Washington Hilton here in Washington. And we had a very interesting attendance from everybody who seemed to be interested in networking. Some said, you know, this whole notion of packet switching didn't work because it was basically not good data principles. I guess those are the exact words that were used. And yet, over time, it really has replaced the old ways of dealing with communications through circuit switching. I also tried to get a large number of companies to show up and demonstrate how the internet could be used, or the ARPANET back in those days, by many different organizations working together. And I would say that every single party in industry that I talked to that was dealing with applications basically wanted no part of it. Because they said they have a system and they would like people on their network to use their system, and they don't want to put them on a network where they can go to somebody else's system. They want to facilitate that. And I think some of these issues exist today. So we saw it was a long run-up period where before industry got into the internet. I mean, it was probably 10 years since it was first introduced. I can also state categorically, because I have it up on my wall, the internet was declared Product of the Year by Internet World, which was one of the main publications, in 1993. I think they really meant the web, but they called it the internet, and that's still a confusion to many people. It was 20 years after we first introduced it in a fundamental way. You're going to see some of that about what I want to talk about today. So I want to start out with the notion of blocks. On the very first slide, I titled it Blocks as Digital Objects. Well, blocks show up in the word blockchain, obviously, or the word block does, but the term blocks has been around for many, many years. If you go on Wikipedia and just see what it says about blocks, it's going to talk about it in a communications context where people did block coding and people sent blocks of data across telecommunication channels. And chaining of those operations was also pretty usable and useful in space communications, where, for example, if you wanted to communicate with Mars, where it took quite a long time, you couldn't do microsecond or millisecond kind of interactions. And so what they would do was send the data over and over again, and they'd often chain it to the data that came before by XORing it with the next block. And so the blocks were all chained, and you could see when things went wrong. Or in coding theory, where if you did convolutional coding, for those of you who know about this coding field, you essentially do the next piece of code based on the code that came before it. And when you go to decode it, you can usually tell when something's gone wrong because nothing seems to look proper anymore. And so you backtrack and go down another path. And so for people in the communications field, this has sort of been a natural concept. Now, they weren't trying to do what the blockchain is trying to do, but conceptually, they had similarities. In the computer science field, things like programming languages, a Lisp programming language, which I grew up with, was essentially, linked pieces of data, and everything could link to each other. And you could put in, cryptographic chaining or not, and you could deal with that in many different ways, but it was not a new notion in the computer field either. But they still weren't trying to do what's being tried to be done with blockchains. So let me go forward and give you a little bit of background on something which I call the digital object architecture. This is something people think is proprietary. I'm here to tell you categorically, it's in the public domain. And it's an architecture. People can have proprietary implementations. I would hope that just like we had with the internet, people took the protocols, TCP/IP, which was a method of achieving interoperability, and they all built their own proprietary implementations, but they worked according to some well-defined interoperability standards, which you could also test on the nascent internet at the time. So if I were going to date this work, I would date it back to the 1980s, when a colleague of mine who I worked with on the internet protocols named Vint Cerf, and I developed the concept of mobile programs. We wrote a paper on it called The World of Nobots, and the whole idea there was to get people who were used to being with fingers on keyboards and noses on screens to free themselves up, talk to these mobile programs, maybe by voice or some other way, program them to do their bidding for the day, let them go out on the net, and you could check in with them occasionally. So they're mobile agents, as you will. That showed up at the time when the first of the viruses or worms on the internet were showing up, and many of the companies that we talked to, that work was actually funded by a number of companies. It showed up just at the time, I think the Morris worm was around that time, and people were saying, oh, we don't want a system that allows mobile programs that come from somebody else to show up on our machine and run. And so we really got no uptake on that, but what we did get was a lot of interest in working with the university community, which wanted to digitize its collections. This was slightly before the web. And so DARPA funded a project called the Computer Science Technical Reports Project, which funded a number of US universities to digitize their collections, to build digital libraries, and to perform research on that. Now, this was a problem that to me looked just like the problem of the internet in the first place. Namely, you were trying to take different systems that were basically information systems written by different people, different internal architectures, and we wanted to make them all work together. And how would you do that? Well, you need to be able to identify what information you wanted. You needed to make different systems interoperate. In many ways, this was identical to the internet challenge that we faced, where we're just trying to get bits from one place to another. And so we developed that architecture, working with Berkeley and Stanford and MIT and Carnegie Mellon, Cornell, and others. We very quickly got the Library of Congress involved. They were one of the very first users. They still make use of this system today. In the middle 1990s, when the internet was first being unveiled in many people's view, industry got very interested, and we set up a consortium not too dissimilar from this in terms of bringing people together. A lot of the main IT companies, communication companies, semiconductor firms, publishers, and the like. It was called the Cross-Industry Working Team. And they produced a report in the middle 1990s that I commend to all of you. I think there's a few copies we brought with us, but there's a citation and the reading at the back of this, so you can pull it off the net. It was entitled something like Managing Access to Digital Objects. And the subtitle really had to do with what these were and how you perform stated operations on these digital objects. And the interesting part about that was it was backed by something like 50 or 60 major companies, most of whom are intrinsically interested in blockchains today. This particular work was so visible both in terms of the information management side, but also in the identity side, because to get a piece of information, you needed to identify it. You didn't want to say it was in this journal on page 3, line 2, because it didn't tell you how to get there. And so just like the way we found simple ways to get to computers on the internet through the use of IP addresses or domain names, this was a simple way to get access to this kind of digital material in the form of digital objects. And the digital ID world in 2003 gave it one of their major awards. Actually, they gave it to me, but it was for this architecture. The claim on the award was for balancing innovation with reality. I think the innovation was in terms of the overall architectural concepts, technically, but the reality was that due to the contributions of my wife, Patrice Lyons, who was actually an intellectual property lawyer, it was actually based on solid legal principles for allowing people to manage it. And today, those notions are widely used in the publishing industry, in the entertainment industry, in Hollywood, in certain parts of the financial industry. We're particularly working on managing derivatives that would have been very helpful in unraveling the mortgage industry problems back in 2008. And we're looking at it in a variety of different contexts that I think you would all find interesting. Now, some of those could probably benefit from blockchains. Some of them may not need it, but they're all relative to what's going on here, all important. And this whole architecture is now being evolved through a foundation that is headquartered in Geneva, Switzerland, that I think is going to play an extremely important role going forward for the very narrow core interests that exist in terms of getting interoperable identifier and information systems on a global basis. This is a picture of what that award looked like. I don't know if you can read the bottom, but it just has that citation that I just described for you. And it was very nice when they did that, and the press release that went around with it said that this particular architecture is increasingly being recognized as a possible solution to the Internet of Things interoperability problem. I believe it is, and I'm going to say a little bit more about that later. But there are so many parties around the world today that see the Internet of Things as a very big venture, potentially much larger than anything yet to do with the internet, that a lot of what we experienced in the early days with networking and with the protocols is existing here too. And so we may see a period where multiple companies go out and try and get their particular approach to dealing with it to be the one that takes, because they would like to own it and control it. We had that problem with the telecommunications industry as well. When they first heard about the internet, this was by the late 80s, one of the concerns that they had was this is not what they were trying to do. It came from some other quarter. It was involved with the research community. And so the first thought was, well, let's see if we can kill it, get rid of it. How do you get rid of the internet? So they were looking for a solution to that. When they realized not only was that a bad idea, but for what they wanted to pursue at the time, they might have natural evolutions that might require interoperability as well. About a year later, I got invited to a meeting. I won't go into the details here. This time they decided the argument was right. They shouldn't kill it. They wanted to buy it. They wanted to own it. And so we had a full-day meeting on what they could do to buy the internet. My answer to that was, well, suppose you wanted to buy the world economy. What would you do? Exactly. Not clear. Or suppose you wanted to buy, who's in charge of world health? I mean, there are a lot of people who care a lot about health, ranging from people to governments and everybody in between, but there's nothing you can buy to own world health. No stock, no company, it's a whole capability. And so eventually they decided it was their market. They might as well jump in. And in fact, the telecommunications folks who were most concerned about it now are the major providers of services at the telecommunications level. But lots of other people are involved as well, including many who never thought that they would have an opportunity because it was an open architecture and it enabled anybody who could sort of see a new idea and how to apply it there to make use of it. That's the same thing that's going on with the digital object architecture. It has all the attributes of the internet because it is, in fact, a logical extension of the internet to deal with managing information. When we started, all we were trying to do was get bits from one place to another simply, so you didn't have to ask on what net is that machine, how do I get there, what routers do I go through, what protocols do they use. You could just sort of simply get it there like rapid postcards through an IP-dominated system. I mentioned the cross-industry working team. That's the report they put out. Unfortunately, I couldn't get this to go in portrait modes and landscape mode, so you only see a little bit of it. So this only shows 6 companies there. 7 companies. So it's got what? Apple is on there, AT&T is on there, BBN, Bell Atlantic. But the list was much longer. This only goes up to the first 2 entries on the Bs. So that's a report I commend to you, and it's still one that I think is very relevant to everything that's going on with the blockchain stuff. Now, I've also been sufficiently intrigued that I'm going to go over your time by a few minutes by agreement. A lot of the patent applications and papers written talk about blocks and blockchains. So, and they refer to them as these blocks as digital objects. So I want to try and explain why that is the case. First of all, for a blockchain to be useful, you need to be able to understand which blockchain you're talking about. So you need to be able to identify these blockchains somehow. And if you've got multiple ones, they do need to be interoperability. These interests are all really collaborative interests. And so it's a very interesting multi-party solution to an important problem. It's not the only solution, however. I'm going to give you one example on the next slide of how you can engender trust without having to rely on an external party in a direct way. But architecturally, what you need to do is think about a blockchain as a digital object, because what is a digital object? If you read those papers, it's just a sequence of bits or a set of sequences. Could be a set because you might have, let's say, something that's just got different pieces to it, like audio and video, or it could be in different forms. It could be maps that have details about it and so forth. But they need a unique identifier. In many cases, in the publications industry, they need them to be persistent. They'd like them to last forever, but that's just sort of their need. Now we have the issue of mutability versus immutability. An immutable object, that is one that you don't want to change. It's a contract, it's a financial transaction that took place, it's a digital cash issued by the Federal Reserve, maybe it's a patient's record as of the given year. You're not going to go back and change it for that year. Every one of these can in fact be authenticated without relying on anything as complicated as a blockchain. For example, if the identifier for that had a fingerprint, let's say a strong enough cryptographic fingerprint in the identifier, if you could somehow get the object, and I'm not going to specify what that could be, it shows up from many systems, it could be a bogus object, you can verify whether you got the right one just from your identifier without having to rely on any other party for trust. Now, you may not get the object, which is a separate issue, but if you've got a system that purports to be reliable in producing it, you can trust what you get back that way. Now, a mutable object is one that can change, and therefore you can't check it from the identifier. Where am I? Yeah, sorry. You can't check on it from the identifier itself, so you need to rely on an external mechanism of some sort. But if you think that a block is immutable because a particular transaction you would never go back and change, a blockchain may not change. It could be immutable, but in general, you think of a blockchain as something that wants to change over time as you put more transactions into it and the like. So I want to now talk a little bit about identifier systems. So given an identifier, and given an information could be in lots of places, I think in principle they could be in every device that's around, because you need a place to store these objects. It could be your personal objects, it could be other things. Let's say you had, 10 billion, or they're talking about for Internet of Things, let's say at 100 billion devices, which of those do you go to get the data you want? And I'm thinking every one of those devices are going to be little mini information systems in their own right. And the reason I say that is because, if it's a thermostat and it has a temperature reading, it's one thing to say that's all you can get, but maybe it's got a little chip on it that'll let it collect the last week's data, the last month's data, and you can interoperate with it very easily. Well, that's a little information system, and what I talked about in the CSTR project would apply here too. You want to make them interoperable, you want to be able to ask it, what's the average temperature been here for the last week, or maybe it's financial transactions and you aggregate them. You want to say something about the transactions for a given company or a given country, or the economy globally perhaps. So you need a way of knowing which of those guys to ask, and one way to do it is to have a system that you can say, here's the identifier, please tell me where to go. And that's what we thought about for this thing called the handle system originally. Oh, I missed my, the slides are out of order. Okay. So let's see. So that's one of the things we thought about. Let me put this in context to you first. I'm just going to go through this really quickly to give you a feeling for what the digital object architecture is. You've got a client and he needs to find something. He needs a way to discover resources. I don't know if this is going to work as a pointer, yeah. So you need a resource discovery thing. We think of those as registries. That's what the entertainment industry uses. A number of people do. We've prototyped them in different in different forms, including in the health industry, including in a variety of different ones, including financial industry as well. Then those will give you identifiers. So the identifiers can then take you to the repositories. And those repositories, as you'll see in my next slides, are all interacted with by virtue of identifiers, which guarantees that anybody around the world running repositories can have them become interoperable. So it is a solution to this problem of interoperability that everybody says we need to solve, and it does it in a very simple and abstract way by just passing around identifiers. And then the problem is, though, if you've got an identifier and it says what repository to go to, you're fine. The problem is, we found out early, in fact, through discussions with banks and other companies, they wanted to control that information themselves. The hospitals do, the companies do, the banks do. And so you might have, today we've got probably, I would say 10,000 agreements with people around the globe to run local handle services, of which a single one with the publishers probably has more than 200 million entries in it alone for digital objects. I think some of the work on Internet of Things dealing with the food supply chain have over 1 billion things identified that way already around the world. So which of those companies do you ask for? The answer is, well, you could either build a single database that's got too many of these things, or you could go to a different form where you actually empower people to run them by giving them essentially numbers to create identifiers from. And I'm going to explain how that works in a minute. But that's what the handle system is about. So it's logically a single system, but it's physically and organizationally distributed. Associated with this identifier are certain stated values like IP addresses, public keys, URLs if you're using the web, metadata in general. And it's got secure resolution and administration using PKI, which in some cases may be mandatory, in other cases is optional. And it's totally compatible with the DNS, although it's not dependent on it. To just give you a feeling for, I'm not going to go through the details of how this works, but this gives you a feeling of what the system looks like. So a user would come in, there's a global handle registry, and you give it an identifier, and you come back and say, okay, that identifier, the whereabouts of it would be known by this organization. They were given a prefix, so they append a number to it, like our street address is 1895, so everything we do starts with 1895. And so we can generate more of them ourselves. And then there are all these local handle services, which you see here. This is the global, and you see are represented. That's a big distributed system too, in an interesting way. And then you got these local handle services, which are distributed around the globe, and they can have multiple implementations with one workstation or 100 workstations. So when I say that this is a simple system, it's sort of got a place, you give an identifier, and it tells you back what to do. It's in the form of the handle record. It's actually a complex system, but simple to understand. So this is just describing how the resolution goes. This is what the repository concept looks like. It's not a storage mechanism specifically. It's for managing storage. So the storage is back here. It's where the digital objects are. But the front part is what we call the repository software, and it's really a logical interface. It takes an identifier in through this digital object protocol. It lets you deal directly with the object. So if that were a medical record, you could ask the medical record to give you a blood pressure reading or a cholesterol reading or whatever. You wouldn't have to move the whole file back, and you deal directly with that object wherever it might be around the globe. Now, a digital object can also contain other digital objects, which is an important notion because that's sort of how I think about the blockchain as a big digital object that's got a lot of other digital objects embedded within it. And these digital objects contain metadata. So I'm not going to describe this, but roughly speaking, the operation has an input if you're depositing something, an operation ID if you want to do an operation, and that operation is described with an identifier. It's got an object ID. This is the target of the operation, maybe some parameters like maybe the blood pressure reading, and output if you're trying to get stuff out. And there's validation both ways through PKI. So you won't get a record if you're not entitled to it. Security is pretty much built in. Now, there was a standard out of ITU based on the digital object architecture and its recommendation X.1255. And it came out of an identity management activity, but it's actually broader than that because it lets you discover registries, it lets you find out information, but it's a structural piece of the whole thing. This could be something that could be used to discover blockchains, for example. And in that particular report, these digital objects are defined as digital entities that have to do with the politics of ITU. But digital entities and digital objects, in my mind, are basically the same thing. And a key part of these objects is something about data typing. You need to know what the entries are in these objects. And so this is something that we are playing a major role in ISO. It's part of a larger activity, and anybody's welcome to come and join to see if we can get standard ways of representing data types, so you know what the things are that are in these records. Now, in January of 2014, after a lot of inputs, we ended up creating a foundation in Geneva, Switzerland. It's called the DONA Foundation. Originally, that was Digital Object Numbering Authority. Turns out authority was not a word that you can use in Switzerland, apparently, unless it's a governmental thing. So we ended up calling it the DONA Foundation. And this coordinates the digital object activity. It deals with evolution of standards and certain software, and it does pilot projects and outreach, so people can learn about it through that mechanism. It also promotes this recommendation and applications of the DOA in many different countries, domains, and industries, mainly through pilot projects. We expect industry to pick this up and go with it if those pilot projects ever lead to something. So this is not a business that the foundation is in or whatever. But it does support the core standards, like the interface protocols that have to be maintained consistent, and makes them publicly available. And it provides the overall administration for this central piece, this global handle registry that I described. And it's the one that credentials the administrators. So I've just got a few more slides here. I know you're coming to the end of this, but let me just say, this is an organization that is somebody that provides DHR services that's credentialed and authorized by the foundation to create derived prefixes from its credentials. So it gives them a number. So for example, since we were the first to do it, and we've been providing these kind of services now for the last 20 years, so this is not a new facility. In fact, most of the journals will use it. If you look at the medical journals, you'll find most of all of them have what the publishers have branded these handles. They're called DOIs. You'll see them almost everywhere. So we have given out these numbers through the foundation, and people now around the globe can do that. So countries, for example, or organizations that wanted to use the system but were uncomfortable with a US-centric role can now do it and find a centric role somewhere else around the world. One of the first adopters of it was in the European community, where a lot of the folks working on big data and in fact, large research data sets principally adopted this. There's a thing called the Research Data Alliance that the European Union and the US set up. It's one of the main proponents of it. And what these organizations can do is create an unlimited number of derived prefixes from that one number, because they're empowered to do that. Now anybody in the world can discover it, and makes it easy for interoperability between all these different parties. So I'm not going to describe this, but this will give you a feeling for what happens. These are on the outskirts, the center part of where all the global handle records are. These are the ones that are given out just to these administrators. But you can have different parties out there, including the foundation itself, which puts in some material that has to do with who's been credentialed. And they all replicate each other's prefixes down to one delimiter. So if they give 2 or 3 or 4 delimiter prefixes, you don't see that. And that's really important to places that are very sensitive to anybody else ever seeing. Anyway, this is what it looks like in a nutshell. These guys around the side here, these are the MPAs, these are the administrators, and Donna is another one of them, and they feed these records in their GHR records. And when all is said and done, You can't see it in this one for some reason, but they all share them with them in a very trusted kind of scenario. So it'd be interesting to compare that some ways with what's going on here, because they're all cryptographically validated and the like. Community interests, well, the foundation will work with others to enable development of the relative standards about the digital object architecture in connection with either the use of the handle system or other components. And the examples we're currently working on with people are in the IoT itself, which was cited in that original award, big data, research data sets, various distributed resources, and most importantly, the use of the handle system and the digital object architecture more generally to enable interoperability, either with other identifier systems so that they can work together, and we've demonstrated that, or with different information systems. So that's I think my next to last slide that you need to look at. It's the last one you need to look at. So I think there's a basic need in this community to associate unique identifiers with blocks or blockchains and other digital objects of various kinds, and to get interoperability with people who may choose not to use blockchains initially but need to interact with them. There's a very big world out there. So I would encourage this community to think about making use of the handle system, which can be separately branded, as you see the publishers did with the DOI, and I think the entertainment industry, they call them EIDRs, the EIDRs, and take a look at the DO registries and repositories, because they're out there, public use, totally open source. You can use them whether you store blockchains or anything else. It's a mechanism for making this all happen without having to recreate that. And this foundation really does have global reach. I didn't mention kind of who all is involved, but right now we have 7 administrators. We're probably going to have 10 by the end of this year. There are 2 of them in Africa. One is an agency that was set up in South Africa, another one that was a coalition of, I think, 11 sub-Saharan African countries led by the president of Rwanda. And there's another one that's in Europe. It's kind of led by the Max Planck Society, but it involves the data site activity, which is based in the UK and I think Finland as well. We have CNRI clearly doing one. The publishing group is doing it through the IDF. And we have a coalition in China that's actually dealing with it, partly governmental, partly private sector, and partly a venture capital group that's investing over there. We expect probably 3 more this year, as I said, and we'll be seeing how those participate. We get, people will end up saying we'd like to be part of it. And we're going to open this up after we get to something like 12 administrators to anybody else who might be interested. So if there are people who are interested up front, we'd like to know about it now, because we might be able to fast track you if you're interested in participating in this. It really is a global system, and it's got a very large number of interests and probably billions of digital objects currently identified. And the last slide you can get in the handout from the group. It's just some interesting reading that you might find, including papers that, here's one down here that I wrote with Patrice, representing value as digital objects. And it was really motivated by some financial considerations, but it's a general treatment of it. It's not at the level of specificity of here's what to implement and here's how to do it. It's talking about the problem and why it's important. So thank you all for your time. Appreciate the interest.